Good evening, guys. Today we're looking at a question where we have to decide whether or not the outcomes are independent or dependent, and whether or not what happens prior affects what will happen later. So, the weather on a long weekend will either be fine or rainy each day, with each outcome being equally likely. Okay, so question A. Draw a tree diagram to show the possible outcomes for Saturday, Sunday, then Monday. Alright, so before we start this question, just reading through, the weather on a long weekend will either be fine or rain each day, with each outcome being equally likely. So it doesn't matter if it rains on Saturday, you still have a 50-50 chance of raining on Sunday. It doesn't matter if it rains on Saturday, then is dry on Sunday. You still have a 50-50 chance of Monday being either fine or rainy. Alright, so let's just get to it. We're going to have to draw a tree diagram. And the first part, we're going to have it if it's rainy or if it is not rainy, which you can say is fine. I just like to draw an R with a line on the top, which means not R. Okay, so that was for Saturday. Sunday. Well, if it had rained, you could either have it rain again, or you could have it not rain. And if it had rained on Saturday, on Sunday, it could rain then, or it could not rain. And finally, we need to do Monday. So let's say that it has rained on Saturday, rained on Sunday. We still have a 50-50 chance that it could rain on Monday, or it could not rain. So, continuing this on, you probably guess where it goes. Rain, not rain, rain, not rain, and rain, not rain. Okie dokie. Now I've drawn my tree diagram. It might help us just a little bit if I draw over here a table of my outcomes. So I've got R for one outcome, not R over here, R, not R, yeah, I'm just talking to myself. After that we've got rain, not rain, and not rain. Rain, not rain, and not rain. We've got not rain, rain, rain. We've got not rain. While we're at it, might as well just fill in. They're all going to be not rains. So we have not rain, rain, rain. Not rain, not rain, rain. And rain, rain, rain. Or not rain, not rain, not rain. So no rain whatsoever. Okay. Now we're going to use this table, as confusing as it looks, to solve our next problem. Okay, so I've just moved it to the side a bit so that we have more space to work with. Question B, what is the probability that it rains on all 3 days? Now if we look down at our list, there's 1, 2, 3, 4, 5, 6, 7, 8 equally likely outcomes. So when we're answering question B, we're always going to have our answer over 8. Now the probability, get rid of that. The probability that it is going to rain on all 3 days, which is is 1 out of 8. And that's because of all these 8 outcomes, only one of them is R. Part 2. What is the probability that it is fine on 2 of the 3 days? Now this is actually a bit trickier because all that I need to find are 2 days when it does not rain. So remember, it's going to be out of 8, and now we need to look at our sample space, which are all these outcomes, and see which days have 2 not raining. So it is fine on 2 of the 3 days, which in other words means it's going to be raining on 1. So we've got 2 rainy days there. I'm not going to count the last one because I'm going to count that as having 3 fine days, not 3, not 2. So there's 1, 2, and so that's a total of 2 out of 8. which is simplified to 1 out of 4. Now for part 3. It is fine on Sunday and Monday, but it rains. Sorry, fine on Saturday and Sunday, but it rains on Monday. Now, that's very specific, and if we go through, it is fine on Saturday and Sunday, but it rains on Monday. There's only one outcome that is like that. So that outcome is, or that probability, or that outcome has a probability of occurring of 1 out of 8. And finally, for question 4, getting close to my time limit, it rains on at least one day of the long weekend. At least one day, which means that if it rains on all 3 days, that counts. So that counts, that counts, that counts. That has at least one day, at least one day, at least one day, at least one day. In fact, the only occurrence that doesn't count is this one, so the probability is 7 out of 8.